Hello viewers, welcome to IIT PAL Mathematics channel. So, this is part of a series of problem solving sessions. I will be giving a few problem solving sessions on integral calculus and differential equations. So, this is lecture 1 of integral calculus. So, let us start by doing some problems. The problems are mainly chosen from previous year's JEE advanced papers, and I will review the important concepts used in the problems along with the problems. So, let us start with problem number 1. So, question 1 says that if I is equal to 2 over pi integral from minus pi by 4 to pi by 4 of dx over 1 plus e to the power sin x times 2 minus cos 2 x, then 27 times I square equal to what? So, basically we have to evaluate this definite integral and then calculate the value of 27 I square. So, if we see here, we have integral of the form minus a to a of f x dx. So, let me recall. So, for any function f x, integral of minus a to a f x dx, this is equal to integral of 0 to a of f of x plus f of minus x dx. So, instead of evaluating from minus a to a, we can just evaluate from 0 to a. So, the proof of this is very simple. So, what we do is integral from minus a to a f x dx, this can be written as integral from minus a to 0 of f x dx plus integral from 0 to a f x dx. This is a simple properties of definite integral, that if we have integral from some a to b, then we can split into sum of two integrals from integral from a to c and c to b. Now, what we do is in the first integral, putting x equal to minus y in the first integral, so if we put x equal to minus y, dx will become minus dy, and when x equal to minus a, y is equal to a, and when x is equal to 0, y is 0. So, integral of minus a to 0 f x dx can be written as integral from a to 0 of f of minus y, and dx is minus dy, which is same thing as minus of integral a to 0 of f of minus y dy, and this can be written as integral from 0 to a of f of minus y dy, which can also be written as integral from 0 to a of f of minus x dx. Therefore, integral from minus a to a f x dx is equal to integral of 0 to a f of minus x plus f of x dx. which is this our formula. Of course, there are two special cases which are important in many problems. So, if f is an odd function, that is f of minus x is equal to minus of f of x, then this f of minus x plus f x will become 0. So, therefore, integral of minus a to a f x dx will be equal to 0. And the second one is if f is an even function, that is f of minus x is equal to f of x for all x, then integral of minus a to a f x dx is same as 2 times integral from 0 to a f x dx. Now let us do the solution to the problem. So, we have f of x is equal to 1 over 1 plus e to the sin x times 2 minus cos 2 x. Now, let us evaluate f of minus x. This is equal to 1 over 1 plus e to the power sin of minus x times 2 minus cos minus 2 x. Now, sin of minus x is minus sin of x. So, this will be equal to 1 plus e to the power minus sin x, and cos is an even function. So, this is same as 2 minus cos 2 x. This can be simplified as e to the power sin x divided by 1 plus e to the sin x times 2 minus cos 2 x. So, we see that the denominator is same as that of f of x. So, now if I add f x plus f minus x, f x plus f minus x is equal to 1 plus e to the sin x divided by 1 plus e to the sin x times 2 minus cos 2 x. So, 1 plus e to the sin x will cancel, and this is equal to 1 over 2 minus cos 2 x. Now, I will use the formula for cos 2 x is equal to 2 cos square x minus 1. So, this is equal to 1 over 3 minus 2 cos square x. So, what we have is the integral I is equal to, we had 2 by pi factor, that will be 0 to pi by 4 of 1 by 3 minus 2 cos square x dx. Now, this integral is not difficult to do. What we can do is, we write this integrand as secant square x divided by 3 secant square x minus 2 dx. And now, it should be obvious to you that if we substitute u equal to tan x, we can write this as 0 to pi by 4 secant square x divided by 3 times 1 plus tan square x minus 2 dx. So, now put u is equal to tan x, then du is secant square x dx, and the integration limit when x is 0, u is equal to tan 0 which is 0, and when x is equal to pi by 4, u is equal to tan pi by 4 which is equal to 1. So, I is equal to 2 over pi integral from 0 to 1 of du over, this was 3 tan square x. So, 3 u square plus 1. Now, this is a standard integral. So, this can be written, if I take 3 common from the denominator, I get 2 over 3 pi integral 0 to 1 du over u square plus 1 by 3, which I will write as 1 by root 3 square. So, this is equal to 2 over 3 pi, and the integral of 1 over u square plus a square is 1 by a. So, 1 by root 3 times tan inverse of u divided by 1 by root 3, and this has to be evaluated between 0 and 1. So, this is equal to 2 by root 3 pi tan inverse root 3 minus tan inverse 0 tan inverse root 3 is equal to pi by 3, and tan inverse 0 is 0. So, we get this. So, I is equal to pi cancels here 2 by 3 root 3. This implies I square will be equal to 4 by 27, which means 27 I square is equal to 4. So, this is the answer to the first problem. So, the question number 2 says find the value of the integral I is equal to integral from 0 to pi by 2 of 3 times square root of cos theta divided by square root of cos theta plus square root of sin theta whole raised to power 5 d theta. So, to solve this problem, what we do is first we substitute theta is equal to pi by 2 minus phi. So, then d theta is equal to minus d phi, and when theta is equal to 0, phi is pi by 2, when theta is pi by 2, phi is equal to 0. Also, cos theta is equal to cos of pi by 2 minus phi, which is equal to sin phi, and sin theta is equal to cos phi. So, the integral will become integral from 0 to pi by 2 of 3 square root of sin phi divided by square root of sin phi plus cos square root of cos phi raised to power 5 d phi. So, note that here I have skipped one step. So, the integral will be from pi by 2 to 0 and then we will have minus d phi, and then the minus of this integral can be written as integral from 0 to pi by 2 of this. Again this integral, instead of phi I can use theta. So, this can also be written as 0 to pi by 2 of 3 square root of sin theta divided by square root of cos theta plus square root of sin theta raised to power 5 d theta. So, now adding this, so let me call the original equation as equation 1 and this one is equation 2. So, adding 1 and 2 we get 2 times I is equal to integral of 0 to pi by 2 3 times square root of cos theta plus square root of sin theta divided by square root of cos theta plus square root of sin theta raised to power 5 d theta. So, now we can cancel this and this will be 0 to pi by 2 3 over square root of cos theta plus square root of sin theta to the power 4 d theta. So, now the problem reduces to evaluating this integral. Now, here again to integrate this one, what we can do is, if I take a square root of cos theta common from the denominator, and this will become 3 over. So, square root of cos theta raised to power 4 will be cos square theta and then we have 1 plus square root of tan theta raised to power 4 d theta. So, now we got tan theta and if you see I can bring in the numerator 3 secant square theta by 1 plus root tan theta raised to power 4 d theta. So, now we can put tan theta is equal to t square, then secant square theta d theta will be equal to 2 t dt, and the limit when theta is equal to 0, t will be is equal to 0, and when theta is pi by 2, tan pi by 2 will be infinity. So, this integral is equal to, so this was 2 I is equal to 0 to infinity of 3 times 2 t dt divided by 1 plus t raised to power 4. So, 2 can be cancelled and this implies I is equal to 3 times integral 0 to infinity t over t plus 1 raised to power 4 dt. Now, this can be easily done by writing this as t plus 1 minus 1 by t plus 1 raised to power 4 dt. So, this is equal to 3 times integral 0 to infinity of t plus 1 raised to power minus 3 dt minus integral 0 to infinity t plus 1 raised to power minus 4 dt, which is equal to 3 times this will give minus 1 by 2 t plus 1 square minus this will become plus 1 by 3 t plus 1 cube from 0 to infinity. Now, as t tends to infinity, 1 by t plus 1 square, this goes to 0 and this also goes to 0. So, this will be equal to 3 times 0 minus, so this will become at t equal to 0, this becomes 1 by 2 minus 1 by 3. So, this is 3 times 1 by 6, which is equal to 1 by 2. So, therefore, the answer is the value of I is equal to 1 by 2. So, let us go to problem number 3. So, again we will evaluate one definite integral. The question is find the value of the integral I is equal to 0 to half of 1 plus root 3 divided by x plus 1 square times 1 minus x raised to power 6 whole raised to power 1 by 4 dx. Let us try to solve this problem. So, first we will do a little simplification and we will write this I is equal to, we have 1 plus root 3 times 0 to half dx over, we have x plus 1 square and then we have power 1 by 4. So, that will become x plus 1 raised to power half times 1 minus x raised to power 6 by 4. So, that is 3 by 2. So, note that in this range 0 to half 1 plus x and 1 minus x are both positive. So, now I will write this as 1 plus root 3 times the integral from 0 to half of dx by, I will write this 1 minus x to the power 3 by 2 as 1 minus x times 1 minus x to the power half. So, we have 1 plus x to the power half and 1 minus x to the power half. So, that will become square root of 1 minus x square. So, we get dx by 1 minus x times 1 minus x square under square root. Now, here we have a simple substitution, because we have this 1 minus x square term, we should try substitution x equal to sin theta. So, then dx will be equal to cos theta d theta, and when x is 0, theta is equal to 0, and when x is equal to half, sin theta is half. So, theta is pi by 6. So, therefore, this integral I is equal to root 3 plus 1 times the integral of 0 to pi by 6 of dx is cos theta d theta divided by 1 minus sin theta, and square root of 1 minus x square is equal to cos theta. So, cos theta cancels and we get integral of d theta by 1 minus sin theta. Now, this is straightforward. What we do is you multiply and divide by 1 plus sin theta, then it becomes 1 plus sin theta divided by 1 minus sin square theta. So, that is cos square theta d theta. This is equal to root 3 plus 1 times integral 0 to pi by 6 of 1 by cos square theta is secant square theta plus sin theta by cos square theta is secant theta times tan theta d theta. Now, you must be knowing the integral of this. So, this is equal to root 3 plus 1 times tan theta plus secant theta evaluated between 0 to pi by 6. This is root 3 plus 1 times tan pi by 6 is 1 by root 3 plus secant at pi by 6 is 2 by root 3 minus tan 0 is 0 and secant 0 is 1. This is root 3 plus 1 times this is 3 by root 3 minus 1. So, root 3 plus 1 times root 3 minus 1, which is equal to 3 minus 1, which is 2. So, therefore, the value of the integral is equal to 2. So, let us move to next problem. Question number 4. So, the problem says that let f from R to R be a differentiable function such that f of 0 is equal to 0, f at pi by 2 is equal to 3 and f prime at 0 is equal to 1. So, we are given a differentiable function whose values at 0 and pi by 2 are given and f prime 0 is given. Now, if g of x is equal to integral from x to pi by 2 of f prime t cosec t minus cot t cosec t f t dt for x in 0 to pi by 2, open at 0 and close at pi by 2, then we have to find limit of g of x as x approaches 0. So, this g of x is given in terms of this integral. So, first we should try to evaluate this integral to find the formula for g of x, and then we will try to find this limit. So, note that here if you see the integrand, it is f prime t cosec t minus cosec t cot t f t. This is nothing but the derivative of f of t times cosec t. Because if we use product rule for derivative, then this gives derivative of f prime t times cosec t, and derivative of cosec t is minus cosec t times cot t. So, therefore, this g of x is equal to integral from x to pi by 2 of d by dt of f t cosec t dt. So, once we know the antiderivative of the integrand, then by the fundamental theorem of calculus, this is equal to f t cosec t evaluated between x and pi by 2. So, that is equal to f of pi by 2 times cosec pi by 2 minus f of x cosec x. Now, f of pi by 2 was given to us, f of pi by 2 is equal to 3. So, this is equal to 3, cosec pi by 2 is 1. So, this is 3 minus f x cosec x. So, note that cosec x is 1 by sin x. So, it is not defined at x equal to 0. So, note that cosec 0 is not defined. So, we cannot find g of 0, but we can try to find the limit, but limit of g of x as x approaches 0 is equal to 3 minus limit x approaching 0 of f x times cosec x. I can write as f x by sin x. So, now we have this is 0 by 0 form. Now, we know that the limit of sin x by x as x approaches 0 is 1. So, this I can write as 3 minus limit x tends to 0 of f x by x divided by sin x by x. Now, the denominator we know the limit is 1. So, this is equal to 3 minus limit x approaching 0 of f x by x. This is because limit of sin x by x as x approaches 0 is equal to 1. Now, somehow we have to make use of the derivative of f at 0 is given to us, which is 1. So, this is equal to 3 minus limit x tends to 0 of f x minus f 0 by x minus 0. This is because f 0 is given to be equal to 0. So, now we know that this limit is nothing but the derivative of f at 0. So, this is 3 minus f prime 0, and f prime 0 is given to be equal to 1. So, this is 3 minus 1, which is equal to 2. So, the answer is limit of x tends to 0 of g of x is equal to 2. So, I would like to make one comment here. So, note that here we have this limit of f x by sin x, which is of 0 by 0 form. So, you might think of applying L'Hopital rule directly here. So, if we apply L'Hopital rule, then this will be equal to limit of f prime x by cos x, and then limit of cos x as x approaches 0 is 1. So, that is limit of f prime x as x approaches 0, and then you can think of writing that as f prime 0. So, you will directly get this 3 minus f prime 0, but note that to write limit of f prime x as x approaches 0 equal to f prime of 0, we need to know that f prime is continuous at 0, but if you see the problem, it is only given that f is a differentiable function, but the derivative need not be continuous. So, therefore, that is not a correct reasoning. So, therefore, we have written this limit as this derivative at 0 and then evaluated this. So, this finishes problem number 4. Let us move to problem number 5, which is slightly different from what we have done so far. So, here we are given if I is equal to summation of k equal to 1 to 98 of integral of k plus 1 by x times x plus 1 dx from k to k plus 1, then we have to choose correct options from the following 4 options. So, A is I is greater than natural log of 99, B is I is less than log 99, C is I is less than 49 by 50, and D is I is greater than 49 by 50. So, of course, here if you see this integral of k plus 1 by x times x plus 1 dx, this can easily be evaluated, because this is say 1 by x times x plus 1 can be written as 1 by x minus 1 by x plus 1, and then you can evaluate this integral, and actually you can get an expression for I. But using that getting these inequalities might be difficult. So, what in these kind of problems we should try to look at the options and then try to see how to do it. So, if you see the option A and B, then I is compared with natural log of 99. So, now note that what is log 99? Note that log of 99 is nothing but integral of 1 by x dx from 1 to 99, because the antiderivative of 1 by x is log x. So, we get this, and this can be written as summation of k equal to 1 to 98 of integral k to k plus 1 1 by x dx, because for k equal to 1 you will get integral from 1 to 2, and for k equal to 2 it is integral from 2 to 3 and so on up to integral from 98 to 99. So, this sum will be equal to integral from 1 to 99. So, now if you see, we have written this log 99 in terms of summation for k equal to 1 to 98 of some integral. So, we have to just compare the given integral with this integral to see which one is bigger. So, now note that if my x is greater than k and less than k plus 1, then here we had integral of k plus 1 by x times x plus 1, then we have k plus 1 is less than x plus 1, which implies k plus 1 by x plus 1, this will be less than 1. So, therefore, k plus 1 by x times x plus 1, this is less than 1 by x. So, integral of k to k plus 1 of k plus 1 by x times x plus 1 dx, this is less than integral of 1 by x dx from k to k plus 1. So, this shows that summation of k equal to 1 to 98 integral k to k plus 1 this is less than log 99, this was equal to I. So, therefore, A is false and B is true. So, this I is less than log 99 is true, this one is false. Now, C and D compares I with 49 by 50. So, in fact, if you see the way we have done this part to get that the integral is less than log 99, we can also get a lower bound. So, I greater than something by using. So, similarly, what we can get is this k plus 1 by x is greater than 1 if x is between k and k plus 1. So, here we are using k plus 1 by x as greater than 1. So, therefore, k plus 1 by x times x plus 1, this is bigger than 1 by x plus 1. And now, if I integrate this, then integral of k to k plus 1, k plus 1 by x times x plus 1 dx, this will be greater than integral of k to k plus 1 of 1 by x plus 1 dx, and therefore, I which is summation of this k equal to 1 to 98 of integral k to k plus 1 this is bigger than integral from 1 to 99 of 1 by x plus 1 dx. So, just like we got that I is less than integral of 1 by x dx from 1 to 99, here we are getting it is bigger than 1 integral of 1 by x plus 1 from 1 to 99, and this is equal to log x plus 1 from 1 to 99, which is equal to log of 100 minus log 2, which is equal to log 50. So, now if you see we have to compare with 49 by 50. Now, clearly log 50 is bigger than 1, which is bigger than 49 by 50. So, I is bigger than 49 by 50, this is correct. So, therefore, D is correct and C is false. So, we get D is right and this C is wrong. So, in fact, if you see, we have proved that I is bigger than natural log of 50, which is much bigger than this number given 49/50. So, you might wonder how to get this number 49/50. So, if you see, we have summation from 1 to 98. So, this 49/50 is nothing but 98/100. So, let me write here remark. Note that this 49/50 is equal to 98/100. So, if we can show that this each integral is bigger than 1/100, then the summation will be bigger than 98/100. So, let us look at the integral. So, if we show that integral k to k plus 1 this is bigger than 1/100 for each k, then I will be bigger than 98/100, which is 49/50. So, showing that this integral is bigger than 1/100 is not difficult. So, what I will do is we put x is equal to k plus y. So, what happens if I put x equal to k plus y, then when x is between k and k plus 1, when x is equal to k, y will be equal to 0, and when x is equal to k plus 1, y is equal to 1. So, we can write this integral as integral this is equal to integral from 0 to 1 now, and k plus 1, x is equal to k plus y times x plus 1 is k plus 1 plus y dy. Now, because y is varying between 0 and 1, and k plus 1 is bigger than k plus y. So, this is bigger than integral from 0 to 1 by k plus 1 plus y dy. This is since k plus 1 by k plus y, this is bigger than 1. And now, if you see this integrand 1 by k plus 1 plus y, this is bigger than 1 by k plus 2, and the integral is from 0 to 1 dy, that gives 1. So, this integral is bigger than 1 by k plus 2. Now, k varies from 1 to 98. So, this is always bigger than equal to 1 by 100 if k is between 1 and 98. So, we have proved that this integral is bigger than 1 by 100. In fact, we can get a better bound by using this is bigger than 1 by k plus 2 and then summing it from k equal to 1 to 98. So, we can get that this D is true by this way also. Okay, let us do one more problem. So, question number 6. So, we are given a function, let f r to r be defined by f x equal to greatest integer of x if x is less than equal to 2 and 0 if x is greater than 2. Now, if I is equal to integral from minus 1 to 2 x times f of x square divided by 2 plus f x plus 1 dx, then we have to find the value of I. So, to do this problem, first let us recall that the greatest integer function, this is the greatest integer less than or equal to x. So, this is equal to n if x is greater than equal to n and strictly less than n plus 1 for any integer n. So, we have, if you see, f of x is defined to be greatest integer of x if x is less than equal to 2 and 0 for x bigger than 2. Now, I is integral of this. So, let us write g of x is equal to x times f of x square divided by 2 plus f x plus 1. Now, f of x square is greatest integer of x square if x square is less than equal to 2 and 0 if x square is bigger than 2. What is this equal to? So, x square is less than equal to 2 means x between minus root 2 to root 2, it is given by greatest integer of x square. Now, greatest integer of x square, this will be equal to 0 if x is between minus 1 to 1, because in this case x square will be strictly less than 1. So, greatest integer will be 0, and if x is greater than equal to 1 and strictly less than root 2, then x square is greater than equal to 1 and strictly less than 2. So, the greatest integer of x square will be 1, and if of course, x bigger than root 2, then x square is bigger than 2. So, this is equal to 0. So, because we have to integrate from minus 1 to 2. So, that is why I have started only for x bigger than minus 1, and f of x plus 1, if you see, this is equal to greatest integer of x plus 1 if x plus 1 is less than equal to 2 and 0 if x plus 1 is bigger than 2. So, this is equal to greatest integer of x plus 1 if my x is between minus 1 x is less than equal to 1 and this is 0 if x is bigger than 1. Now, again this greatest integer of x plus 1, this will be equal to 0 if x is less than 0 and greater than equal to minus 1, and if x is greater than equal to 0 and less than 1, then x plus 1 is greater than equal to 1 and less than 2. So, the greatest integer will be 1 and this is equal to 0 if x is bigger than 1. So, now we can write g of x, this was x times f x square by 2 plus f of x plus 1. So, if you see f of x square is non-zero only between 1 and root 2. So, if x is greater than equal to 1 and less than root 2, then this is x times f x square is 1 divided by 2 plus f of x plus 1 is, because x is bigger than 1, this will be equal to 0 and this is 0 if x is bigger than root 2. So, g of x is equal to x by 2 if 1 is less than equal to x less than root 2 and 0 otherwise. So, now I is equal to integral of minus 1 to 2 of g of x dx. This we write as integral from minus 1 to 1 g x dx plus integral of 1 to root 2 g x dx plus integral root 2 to 2 g of x dx. Now, here g of x is 0 in the first interval and the last one. So, this is equal to 1 to root 2 of x by 2 dx, which comes out to be x square by 4 evaluated between 1 and root 2, and this gives answer as 1 by 4 times 2 minus 1, which is 1 by 4. So, I is equal to 1 by 4 is the answer. All right. So, this finishes lecture 1 on integral calculus. In the next lecture, we will discuss some more problems on integration. Thank you.